Hello all. So in the last session we were talking about central tendency and variability in statistical learning, where central tendency will actually give us one point of value representing the entire data. We have seen mean, median, mode are different measures of central tendency, and we've also seen variability which will actually gives us how far the data points are spread in the data. So today in this session I would like to talk about three important other terminology in statistical learning, which are correlation, covariance and causation. Okay, so these three are important concepts when we learn about statistical learning and machine learning. These three will actually gives us relation between the variables. Okay, when I talk about a data set, I'll have different variables or different columns in the data set, and we will learn the relation between each and every variable with respect to correlation, covariance and causation. All three hold different importance. So let's discuss correlation first. Okay, so correlation actually measures the strength and direction of the linear relationship between two variables. So if I am talking about variables in the data set, okay, so to understand how are the two variables dependent on each other, we go for correlation. The relationship between two variables is actually given by the correlation. Okay, so the correlation values are usually normalized between +1 and -1, where +1 represents the positive correlation, perfect positive correlation. Okay, so as you can see, this is the perfect positive correlation. As my x is increasing, my output is also increasing. Okay, and then the second one represents 0, that is no correlation at all the points are randomly spread. Okay, so when I talk about the last one, which is negative correlation, as x is increasing, my y value is gradually decreasing. So these are three different notations of how the correlation is represented, that is how is each variable dependent or related to another variable in the data set. Okay, so we have different types of correlation. Most probably we'll be talking about Pearson correlation and Spearman rank correlation. In machine learning, most of the times we'll be using Pearson correlation. Okay, so this is a formula. Pearson correlation is actually represented by R, and this is the formula. So summation of xi minus x bar into yi minus y cap by square root of summation of xi minus x cap whole square into summation of yi minus y cap whole square. Here when I talk about xi, they are nothing but the individual data points, and x cap is nothing but the mean. Okay, so the different summation of the difference between the individual data points and the mean value. Okay, so this is how your Pearson correlation is calculated. Okay, now what is the actual need for calculating correlation in machine learning? Okay, so correlation, as told, will give you the linear relationship between the features or variables in the data set. Okay, so when we talk about data pre-processing next, after statistical learning, we will be looking into data pre-processing. Okay, when I want to pre-process the data, I have to remove the unwanted columns. So when I want to remove the unwanted columns, I have to check the relationship between different columns or different features available in the data set, for which we will be going for correlation, calculating correlation. Okay, so for example, in a data set with features like height and weight. Okay, so when I talk about height and weight, there is likely to be high correlation, because depending on as the height increases, the weight is also increasing. Okay, so there is likely high correlation between these two terms. Okay, including both height and weight in a model too. We require both height and weight in the model. I can't eliminate both of them, because they are very important for me to analyze the given data. Okay, so high correlation value will actually inform us about the dependency of each and every variable, so that we can avoid multi-collinearity. Okay, so when do we use correlation in machine learning? When we talk about feature selection. If suppose I have 100 variables in the given data set, and I don't want to take 100 variables because the processing time would be more. Okay, if I don't want to process all the features, okay, I'll check the important features and remove the unwanted features in the data set. So for which we will calculate the relation between each and every variable, and if they are highly correlated, I can remove them such that I can avoid multi-collinearity. Okay, so in models like linear regression, we have highly correlated features that can lead to multi-collinearity. Okay, so when we talk about multi-collinearity, this will actually reduce the model's performance. Hence, by using correlation, we will actually identify the important features and eliminate the rest. Okay, next when we talk about covariance. Okay, so covariance will actually measure how two variables vary together. Okay, how two variables vary together. Okay, so we have two values representing here. So we have a positive value and we have negative value. When I say positive value, that indicates that as one variable increases, the other also increase, or if one variable decreases, the other also decreases. Okay, so how different variables are varying together. When I talk about negative value, that indicates the inverse relationship. That is, covariance does not actually give the strength. Okay, this is not related to correlation. This will actually say how is one variable similar to another variable. If one is increasing, the other may increase or decrease. Okay, so if one is increasing, the other also should increase. If one is decreasing, the other should also decrease, or else the opposite way. Okay, so positive value indicates one variable increasing, the other variable is also increasing. Negative value says one variable increasing, the other variable decreasing. Okay, so this is your covariance, and the formula for covariance is covariance of x and y, where x and y are two different features. 1 by n minus 1, n represents the total samples in the data set, summation of the difference between the individual data point and the mean. Okay, now when do we use this covariance? Okay, so covariance is actually used to reduce the dimensions of the data set. Okay, so we have principal component analysis, which is one of the important dimensionality reduction technique. So in that principal component analysis, we will be using covariance. Okay, we'll talk about all this in the coming chapters. Okay, so in the data set with features like height and weight, covariance will actually help us understand how much of the variation is there in the data set between these two variables. Okay, so PC, as I told you, if we use covariance when we talk about dimensionality reduction, that is with respect to principal component analysis. Okay, and the last one which I want to talk about is causation. Okay, causation is totally different from correlation and covariance. Causation actually refers to the cause and effect relationship when one variable directly affects another. Okay, sometimes the variables are dependent on each other, so one variable may have adverse effect on the functionality of other variable. Okay, so that effect is represented by causation. Okay, so causation does correlation does not imply causation, and the vice versa. Okay, so for example, if an increase in advertising leads to increased sales, you may refer a causal relationship, but you could also need further analysis. Okay, the sales may not be dependent only on advertising, but there may be other parameters also, like domain knowledge, the experiment made on that, or the reviews and ratings of the product, and so on. Okay, so this is all about the causation, how one variable is affecting the other variables. Okay, advertising leads to increasing sales. Okay, but may not only be on advertising, but also other parameters may affect in increasing the sales. This condition is called as causation. Okay, so while correlation and covariance will actually show the relationship between the variables, causation will actually help us in making crucial decisions in real world when we deal with real world problems. Okay, so for causal inference, for time series analysis, we will be using causation. So this is the summary of use cases. We use correlation for feature selection and to avoid multi-collinearity, that is to reduce multi-collinearity. And then we use covariance for dimensionality reduction, that is for when we deal with principal component analysis, we will be using covariance. And causation will actually give us causal inference between two different variables for decision making and predicting the outputs. Okay, so correlation will actually help us understand the linear relationship and assist in feature selection, that is the variable selection. And covariance will help us in dimensionality reduction techniques, which will ensure which variable to be included and which variable to be discarded. And then causation will help us making decisions based on the dependency of one variable to the other variable. Okay, so this is all about three important concepts in machine learning when we discuss about statistical learning. Thank you.